All right, so one more thing to learn in terms of nomenclature, and that's nomenclature for acids. So we'll touch on acids later on, but for now, what we want to know is that acids are the things that release an H plus, right? H plus. And so there's two main types of acids. The first type is binary acids. And so binary acids are an H plus either a halogen or sulfur, right? So think about halogens, right? Fluorine, chlorine, bromine, iodine, or sulfur. So it's going to be one of these five or six. And so the way this naming goes, it's hydro, blank, whatever the element is, add an ic at the end, and then acid. So hydrobromic acid, hydrochloric acid. So for example, HF would be hydrofluoric acid. One thing to note here is that technically acids must be aqueous. So they must have this kind of AQ sign. So this means aqueous, which means dissolved in water. When you don't see the aqueous, you can still call it an acid. So this would, for example, be hydrochloric acid. However, when you see a gas, when it is in this gas phase, you cannot technically call it an acid. And so this would actually just end up being hydrogen bromide. So a little bit weird, but nothing too bad. So here's an example. Go ahead and name that. Pause the video. Hopefully you did that. This is hydrosulfuric acid. So that's the first type of acid, binary acids, either with a halogen or sulfur with an H at the beginning. And don't forget, it must technically be aqueous. The second type of acids are oxy acids. And so here we have an H and some kind of polyatomic ion. Obviously with oxygen in it. And so the way the name goes here, it's the name of the polyatomic ion. And then depending on if it ends with an 8, it becomes ic. And then you add the word acid. Or if it's an ite, it becomes an us acid, right? So a little bit different here. So you just have to change the name of the ending of the polyatomic ion. This one's a little bit weird, H2 CO3, right? That's carbonate, right? It's CO3 2 minus. You notice we don't do the bicarbonate stuff, and so this is an 8, so it becomes an ic. So this is carbonic acid. Let's do HNO3, HNO2, HClO4, H2SO4, and then H2SO3. So go ahead, pause the video, and name these acids. All right, so first we have HNO3. We know this comes from nitrate, so the 8 becomes an ic, and this becomes nitric acid. Next up, we have NO2. NO2 is nitrite. The ite becomes an us. This is nitrous acid. Next up, we have HClO4. ClO4 is perchlorate. So the 8 becomes an ic, and so this is perchloric acid. Next up, we have H2SO4. SO4 is sulfate. So 8 becomes an ic, and so this actually becomes sulfuric acid. So this one's a little bit weird because you add this extra UR, even though you don't say sulf acid, you say sulfuric acid. So it gets this extra UR, which is a little bit funky. Next up, we have H2SO3, that's sulfite. So it should become sulfurous acid. And again, you add this extra UR just to kind of make it pronounced easier, I guess. Same thing with H3PO4 and H3PO3. This H3PO4 comes from phosphate. So you might think it'd be like phosphoric acid, but it's not. It's actually phosphoric acid, right? So you add this kind of extra or type of thing into here. And then PO3 is phosphite. So you might think it might be like phosphorus acid or something like that. It's not. It's phosphorus acid. So just a little bit more funkiness to it. So in general, in chemistry, there aren't actually too many rules. There's just kind of guidelines. You learn the guidelines, and then you learn the exceptions to these guidelines. So there's your naming of acids.